Oh, sure, start. Okay. So I sent this into group already, this PDF, so you can refer. Okay. This one is on page 16. I will be doing live class for again for essay questions. Okay. For the objective and structural questions, I will soon upload into YouTube. Okay, maybe like around like tonight. Okay. So maybe most of you can upload Thursday. So okay. So in this case, okay. I do like 2 to 3 questions for essay. Okay, so you got 2 experiments carried out. Okay, because based on what I heard, rate of reaction might come out in essay question. So it'll be easy to get mark. Okay, if they come out like question 9 and 10. Okay, I think it's either question 9 or 10. Okay, so you got okay here 2 different experiments. So both zinc powder, concentration same, volume same, type of acid same. What is the difference here? Temperature. Okay. So one have higher temperature, which is Z2. Z2 have higher temperature used. Okay. That's why if you see total volume of gas collected in 2 minutes, same amount of minute, okay, which is like 120 seconds. In 120 seconds, set 1 collected 22 cm cube of gas X. Okay. Set 2 collected 37 cm cube of gas X. So which means, okay, that's why this one collected more gas in the same time. That's why this one have higher rate of reaction. Okay. So they ask for meaning of reaction. Okay, you can write. Okay, change in the quantity of reactant or product per unit time. Can I write that first? Like for meaning what's that? I think like for Q7 they mainly ask what's the meaning of reaction. For Form 1 Chapter 1 they ask what's the meaning of redox reaction. So I think this is the main one. Okay. And then this first one, right? Meaning reaction. Calculate the average reaction for experiment 1 for the first 2 minutes in cm cube per second. This one so simple. Okay. You can just use the volume divided by time. So simple. Okay. So the volume here is not, remember, not taking the volume here. Absolutely not. Okay. Always look at the volume of gas collected. Always. Okay. Normally 99%. Okay. Absolutely 95%. You using the volume of gas divided by time. Okay. So x1 is 22 divided by 120 second. Because 2 minutes, 2 minutes have to times 60 to get 120 second because they want the unit in per second. Be careful. So 22 divided by 60 for experiment 1, which you will get 0.81183 cm cube per second. Just volume divided by time, V over T. Okay. And then gas X, okay, evolved in experiment 2, collected in burette. Okay. Name gas X, calculate maximum volume of gas produced. So normally if they come out this chapter, right, they also frequently come out alongside with a number of more questions. Okay. Most of the time. Okay. Then be like at the end, right, they come out some experiments. Okay. So gas is supposed to be, okay, see what's the relation here. The relation is between zinc and hydrochloric acid. So this one is Zn plus HCl. You will get Zn2 plus attract Cl minus. So you will get zinc chloride salt. And what gas is this? hydrogen gas. Most of the time, I say most of the time, either is metal plus. Okay, you got four, right? Most of the time, it's either you got four experiment. It's either metal, okay, acid plus metal. Sorry, it's either acid plus metal, like you see here. Okay, or sometimes it's like or HCl plus Mg. Example lah. Most common one. The second one is like, and then they come out MgCl2 and hydrogen gas. So the measurement is how much time taken to collect the hydrogen gas. The second one is like acid. Either is acid plus metal carbonate. These two is the most popular one. Okay, like then carbon dioxide and water. Yes. Okay, so if you like H2SO4 plus calcium carbonate, then you will get calcium sulfate. Then you got carbon dioxide, then water. Like that. It means acid react with carbonate, you will get your salt, carbon dioxide gas, and water. These two are the main one. Sometimes you might see maybe in objective, or sometimes you will even see in structures, very seldom you will see the H2O2 hydrogen peroxide. Okay, dissolve. I mean, it will decompose itself, become water and oxygen gas. So either you see H2, CO2, or O2. Okay, either you see either one Yeah. Then the fourth one, by the way, forgot to tell you, if you see anything, catalyst, sometimes they won't tell you this is catalyst. But if you see like acid plus metal, they'll tell you like plus something, something, something. That something for acid plus metal, the catalyst is copper to sulfate. The catalyst is between acid plus metal is copper to sulfate. If it is decomposition of hydrogen peroxide, the catalyst is manganese 4 oxide. Manganese 4 oxide. What's the function of catalyst? Catalyst is to speed up the reaction. Okay, say it can lower the activation energy. Okay, the fourth one will be the X mark question. Okay, below you put X mark one. It's between the sodium thiosulfate and acid. Let's say here, okay, then you will get four things: the salt, sulfur dioxide, water. The most important point is the sulfur, because the sulfur you get yellow precipitate form. Okay, I'm sure you have seen the X mark. Okay, the X mark experiment. It means here we're doing how much time taken for the X mark to disappear when you cover by the X mark. Okay, I mean not covered by X mark, but the X mark will be covered by the yellow precipitate, which is sulfur. Okay, so they become this. Okay, so it means the measurement is how much time taken for the X mark to be disappear from eyesight. Yeah, normally we use only 1 over time as the rate of reaction. Others normally you use like volume over time. Sometimes you might use mass over time. Change of mass over time. Sometimes, very seldom. Okay, as I tell you, the main 4 experiments you learn in this chapter. Okay, but popular one, first, second. Popular one, first and second. Okay, and then gas X is of course hydrogen gas. Okay, calculate the maximum volume. Of course, before you write, you must have the equation to do the number of mole. Okay, so calcium carbonate, not calcium carbonate, sorry. This is C plus HCl, you will get zinc chloride and hydrogen. Balance equation times 2 for HCl. Then you take out the information here. What is the information available? 20 cm cube, 0.1 mole per cube. What information given? 0.1 mole per dm cube is the concentration. In another way, it's called molarity, which is M. Volume is 20. So the formula is mv over 1000, very easy. Okay, so they give you 20 cm cube, 0.1 mole per dm cube. Want to find the volume of gas produced. Okay, so they want to find volume of hydrogen gas. Okay, so number of mole HCl equals to mv over 1000. So 0.1 times 20 over 1000. Which will get 0.002 mole. Okay, then same thing, ratio, then find the volume. So ratio is 2 mole of HCl to 1 mole of H2. So 2 divided by 2 become 1. So it's fine. If you got 0.002 mole of HCl, then divided by 2 you get 0.001 mole of H2. Then because number of mole equals volume over molar volume, if you want to get volume, means number of mole multiply molar volume. So number of mole is 0.001. Molar volume on top given here, 24. So you will get 0.024 dm cube. If you want it in dm cube, you can also change to cm cube by multiplying 1000. So you can also keep that as 24 cm cube after multiplying 1000. Can also. Okay. Either one. Okay. Can. C1 X3 is still using the same as in 7-2, but with higher rate of reaction. Okay. So as you know, the result 2 is already higher than 1 because of the temperature higher. Then they said 3 will be higher. Okay. But they ask for suggest another factor that can be used in experimentary and justify. What do you think you can change? I mean, other than temperature. Yes, you can say you can change concentration. Okay, you got two factors. Either you can change concentration or what else? Because it's already powder, so it means you cannot do anything with the size. So you can change the concentration, or you can change. It cannot do size because it's already powder. It's already very small. Yeah. Yes. Add catalyst. Very good. Okay. So the other one should be adding catalyst. Presence of catalyst. Okay. Why is it? You have to say, you have to explain what is the function of catalyst. What does catalyst do? Yes, you can say add copper sulfate as catalyst. Okay. Add copper sulfate as catalyst. Nothing wrong. Okay. So provides alternative pathway. Okay. I forgot to put way. Actually, no way also can, nothing wrong. Okay, alternative path that can lower the activation energy and finally increase the rate of reaction. You can use either catalyst or you can change the concentration. You choose either one. Anything you like. Okay, because answer scheme can be either one. So you also can change the concentration of HCl. Okay. Wait that. I said sorry. I think I should put higher concentration of hydrochloric acid. Okay. In Malay is lebih tinggi. I think I said I did answer later. So for concentration, you can explain. You can explain number of hydrogen ions per unit volume increase. You have this concentration. Can I choose one? Okay, and then the graph. Okay, they ask for graph. Now, if you choose catalyst, okay, the graph will be just like ending with the same height. Okay, it's just that this one is the third one because the top one is third because using shorter time. The second one will be the bottom one. Okay, this is when you add catalyst. Okay, this way add catalyst. And using shorter time because you added catalyst higher reaction. But if you adjust the concentration, if you draw like this, wrong. Okay, so because there's a domino effect. Okay, if you change concentration, it means the calculation, if you notice, okay, now experiment 2, you see, you will get 24 cm cube. Okay, if you touch the concentration, let's say, okay, you change this to 0.2. There's a domino effect, okay, because if you change this to 0.2, it means here you get 0.004 more, which also means, okay, you will get 0.002 more of H2, and then you will get 48 cm cube. Am I right? So it means the graph ending will be different. So the third experiment will be ending higher. Then it will look something like this. Depends on what you written in C1. So C2, you will get different height. See, if you adjust concentration, then your number of mole will be affected. Volume of gas also affected. See, so the ending will be different. So, but if you only touch the catalyst, didn't affect a number of mole, then the ending will be the same. The amount of gas collected will be the same. So they be careful with this. That's why whenever you see you touch the volume or concentration, the graph will be different. Ended with different height. You choose either one. If you just now write catalyst, then you choose this. If you write concentration factor, then you choose this. Done? 2 marks, drawing with labeling. Okay. Donkey. Okay. The patient's metabolic rate is influenced by blood temperature. Metabolic rates at normal blood temperatures, okay, cause disruption to the patient's blood flow and lead to the risk of brain and other organ damage during surgery due to decrease of oxygen supply. So it means insufficient oxygen. Okay, basically, so it's why blood pressure increase. Okay, so this can be solved by decreasing the patient's metabolic rate. Okay, when the metabolic rate is decreased, okay, the need of oxygen also can be decreased. Okay, so it means you have to decrease the metabolic rate. Okay, so what should we do? Okay, as a housemanship doctor suggests a method to decrease the rate of metabolism and give a reason. So they give you a grandmother story, okay, which is very long, okay, very long, but only 2 months. Okay, so what can you do? Basically, they want to decrease metabolic rate. What can you do? We give medicine, catalyst. This one is human, okay? So, uh, metabolic rates at normal blood temperature. So it means what I can do is metabolic. You know what is metabolism? Eh? Do you know what is metabolism? Okay. 新陈代谢. Yes, 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 yes. Okay. So imagine when is your metabolism is very high? When? In what condition? Running, jogging, yes, very hot, right? So how do you the one you increase metabolism, right? They want decrease what? So what you should do during operation, during operation, lying down, lying down. Of course, he's lying down. She's lying down. Okay. So in this case, okay, very easy, ma. When you do running, jogging, you're very hot, right? So, but they want you increase, right? How to decrease it? In the surgery room. It's why in the surgery room, isn't it? So what happens? During surgery, ma. So you can actually decrease the temperature of operation room. Yeah, this one same, right? When you do exercise, very hot, ma. Okay, but they want this one. They want to decrease the metabolism. So you can just make it cool. Make it cool, then your organ not active. If your organ not active, organ not active, then you also need less. So this is a bit funny question. Okay? So lower temperature of operation room means you can decrease the metabolism, then activities of the brain and other organs also reduced. Everything will be slow lah. Okay. Then if you need less oxygen, then what happen? Then you also what do you say? You also we also will be okay. So metabolism, of course, influenced by the blood temperature. So the normal blood temperature, because if kacau, you disturb the patient's blood flow. Okay, if you kacau patient's blood flow, okay, each my ping, I think we flow very fast. That's a problem. Okay, so it will cause the risk of brain and other organs damage because not enough oxygen, not enough oxygen supply. So they say this problem they can solve by decreasing metabolism. So yeah, okay. Just now you say 新陈代谢, okay, I understand. So yeah, by running, jogging increase, by lowering down temperature, also decreasing. But it's okay. Okay. Diagram 12 below shows 2 packs of sugar that are often used at home. Okay. The rate of solubility in water at room temperature for these 2 types of sugar is different. Okay. One is called fine sugar. One is called the called sugar. Okay, gula halus, gula kasar. Okay, so what I do is based on the factors that affect the rate of solubility of sugar in water mentioned above, plan a method in the lab to evaluate factors that affect the rate of reaction by using other suitable chemicals. Okay, so what can you do? Okay, so the suggest answer number one, okay, they put acid. I think I send answer later soon. Okay, I just explain unless your hand very fast. Okay, so number two, fill burette fully with water. Okay, and invert in the basin of water, clamp the burette vertically. This setup is just similar to this one. Is similar to this. Okay, similar to this. Okay, connect to the burette. Okay, then you collect the gas form. Okay, so and then, where? And then number two and number three. Okay, weight 2.0 gram of marble. You can say calcium carbonate pieces and place in a box. So because based on this here, okay, based on this here, so both are room temperature, but the rate of solubility different because of the fine sugar and the hard sugar. Okay, basically the size a bit different. Okay, so that's why you can carry out another experiment using the same theory, same factor. Okay, with other, let's say with other suitable chemicals. So you can just create calcium carbonate and acid. But when you use calcium carbonate pieces, okay, then you repeat with smaller piece of marble. Simple. Or you can even say calcium carbonate powder. Nothing wrong. So what I do is you put marble chips into the connecting flask, close the connecting flask immediately with rubber stopper, start the stopwatch. Okay, throw the connecting flask, you spin a little bit, you record the burette reading at every 30 seconds interval until the burette is filled with gas. Okay, just like how you calculate, just like how you record the time here. Think in objective got this so-called table. Like how every 30 seconds interval, they collect and they record the amount of gas produced. Okay. Sorry. Okay. And then repeat some of the statistics using smaller piece of mark. Which should be, you can just say the rate of reaction for smaller marble pieces is higher than the larger marble pieces. Better? So this answer. Okay. Don't worry, I'll send you later. Okay, I need to copy now. Okay, just I can go through. Okay. And then question 22. Okay, diagram 9 shows two water temperature options available on the washing machine in the laundry mat. Okay, so option got hot water, cool water. They ask, which water temperature option can clean clothes faster? Explain your answer. So very obvious. The answer should be hot water. But why? What should you say? Temperature in hot water is higher than cold water. Yes. Simple. Okay. Another mark. Yeah. Third point, kinetic energy. Yeah. Okay. So temperature of hot water higher, kinetic energy of water molecule in hot water is higher than cold water. Same question. Because you do before, yeah. Yeah. No wonder. Oh, so you did already. Okay. So they can change many situations. Okay. State two factors, okay, that can affect the rate of reaction other than temperature. So what can you say? And don't you just say you don't just say concentration, you say concentration of reactants. Okay. Will be a better answer. Or you can say size, same thing. Size and concentration. Then okay. So B, okay. So a student carried out three sets of experiment to investigate the factor that affecting the reaction between magnesium and sulfuric acid. Okay. Normally, again, they give you like one or two or three same setup, but maybe they adjust the factor, some of the factor. Okay, like volume, like concentration, like size, like temperature, like catalyst. Okay, so you can see time taken to collect 30 cm of gas. Okay, first is 55 seconds, second is 90 seconds, third is 45 seconds. Which one? Okay, now then the factor. We look at factor. They ask to compare later on, they ask to compare 1 and 2, 2 and 3, right? So based on the direction here, between 1 and 2, what's the difference? One using magnesium powder, the other using magnesium granules. Okay, of course, if you see powder, you know, smaller size, higher rate of reaction. Very simple. Okay, powder, smaller size. Okay. Then second and third, what's the difference? The concentration. Okay. The concentration 2.0. Of course, the concentration higher means rate of reaction also higher. Okay. Again, they ask, write the chemical equation for the reaction in in set 3. Set 3 is magnesium and sulfuric acid. Okay, this one is very easy. So Mg plus H2SO4. Mg, you kick the H out, so you get MgSO4 plus H2 single. It's already balanced. Then they ask for maximum volume of the gas released. So again, once again, H2 equals to, V equals to question mark for H2. Okay. Again, check back what they gave in set 3. So set 3 for molarity is 2.0, 20 cm3 is volume. So once again, first step, same number mole of what they give, H2S4, right? Yeah. They give you 2.0 and 20 cm cube. Okay, so you can straight away MV over 1000, 2.0 times 20 over 1000. So you can get 0.04 mole. Okay, ratio same, but this one is 1 to 1. 1 mole of H2SO4 to 1 mole of H2. But you see it right? Got marks. So 1 mole H2SO4 to 1 mole of H2. If you got 0.04 mole of H2SO4, for H2 also you get 0.04 mole. Then same thing, volume of H2 is number of mole multiply molar volume. So 0.04 multiplied 24. You get 0.96 dm cube, or answer also accept 916 cm. Or to keep as dm cube also can. Simple as that. Easy 5 marks. Easy 5 marks. Okay, this one comparative relation 10 marks question is a bit also of memorizing. Okay, but I try to include every factor. The 4 factors I try to include. Okay, so here, okay, they compare set 1 and set 2. Just now I already told you, right? Set 1, set 2, the difference is the size, right? Set 1, the size smaller. Okay, so set 1 is the one that have higher rate of reaction. Okay, so the sentence, okay, rate of reaction is, sorry, what is what in? Okay, you write off first. I try to edit the answer. Many wrong. Yeah. Wait, interesting. Okay, so you can say rate of reaction in set 1 is higher, size of magnesium in set 1 is smaller. After size, you say total surface area is larger. But the careful thing is, it will say size of what, total surface area of what. I think you can even add, but it's better if you add of magnesium exposed to sulfuric acid. In Malay is bagi magnesium terdedah kepada acid sulfuric. Is in set 1 larger. Okay. Actually, this also wrong. Sorry, dalam. Then the 4th and the 5th sentence, very easy. FOC, FOEC. Okay. Frequency collision. Now this one, be careful. I know the chemical equation is Mg and H2S4, but the sulfate ion is not important. So the real colliding particles should be magnesium atom and hydrogen ion. When you explain, important. Hydrogen and magnesium is by yourself. Then the 5th sentence just repeat with the effective collision. Okay. This is concentration. I mean, not concentration, sorry. This one is size. Then the other one is concentration, isn't it? Set 3 have higher concentration. Okay. Set 3. So set 3, higher concentration, higher rate of reaction. Okay. So you can say rate of reaction is set 3 is higher than set 2. Then you say the concentration also higher. Or you can say higher, you can say double because one is 1.0, the other is 2.0. Say. You can say higher or double. Okay. Now for concentration, after the word after the sentence, many people forget. Okay. So it's the number of particle per unit volume. But the particle here is the acid particle is mainly focused on H plus. So you can say number of hydrogen per unit volume is higher in set 3. Then only the same thing, the frequency of collision, same thing. Between H plus Mg atom is higher in set 3. Then the other one, same thing. Frequency of effective collision between particles is higher in set 3. Or you can want to repeat the whole thing also can. Between hydrogen ion and magnesium atom also can. If I'm very free. Or you want to be safe. Okay. Okay. This one actually, this kind of question, again, okay, the format is kind of like memorizing. So yeah, so like it's around a fixed answer. If they come an essay, can this be hard? Yeah, man. I also say later on you can watch back some of the objective question if you don't understand. Because the original I also compound the question that is quite tricky. So yeah, I say a lot of question steps. I said the video and answer later. Yeah. Okay, don't worry if you haven't done. Don't worry. Okay, I give you 30 seconds more, then I move on. Okay. Think about one more question. Okay. Page 25. Okay. So this one they ask for French fries, fries and wedges. Okay. So shows two situations to cook potatoes. Okay. So refer to table 1. Which situation will the potato cook first? State the factor that influence it and explain how those factors cause potatoes to ripen quickly. Okay, of course, which one cook first? Of course, it's the one. Situation B. Sorry, situation A. A is fries, right? A is fries. Why? Fries has smaller size. Simple. Smaller size, larger total surface area. Choose the situation. Size, total surface area larger than rate of ripening is higher because of more heat energy is absorbed by the fries. Okay, that's why it will increase the rate of ripening. State factor, explain. Can so like it's not exception, you have to just blow more. Okay, blow more points. But again, okay. So I think these three chapter, as I predicted, okay, like to come an essay. So yeah, as expected, most probably. Okay. Redox, yes. Okay. But I explained in the last week already. I settled. Can watch back the video if you miss. Okay. And then a student carried out 3 cell experiment to investigate the factors that affect the rate of reaction. Time taken to collect 40 cm of hydrogen gas is recorded in here. Okay. So you can see, okay, all collecting 40 cm of hydrogen gas. Okay. Set 1 using 90 seconds, set 2 55 seconds, set 3 30 seconds. So later on, if you see the question, they also want to compare rate of reaction set 1, set 2, set 1, set 3. So what's the difference between set 1 and set 2? Eh, actually, I think the question got a bit wrong. I mean, okay, I mean the funny thing is, okay, here's supposed to be 0.2. So I have to yeah, the question itself got a bit wrong. You see the in Malay version they put 0.2. I don't know why. Okay, sometimes they mistakenly put. Okay. So yeah. Then is temperature. Okay, temperature. Higher temperature means higher rate of reaction compared to set 1 and set 2. Then set 2 is 3. They add catalyst X. Okay. So of course, which one have higher reaction? With or without catalyst? With, right? So that's why here they uses lower time. It means higher reaction. Okay. Got catalyst, higher reaction. Okay. So we do the calculation first. Okay. They ask what is catalyst X? Suggest catalyst X. So I told you right just now, if you got acid react with metal, acid react with metal, like here nitric acid react with zinc. This one is the catalyst is copper 2 sulfate, CuS4. Okay, so equation, same thing. Okay, so you got Zn plus nitric acid. Zn2 plus will attract NO3 negative. So you get zinc nitrate salt and hydrogen gas. And then balance equation, H2 means multiply 2 for HNO3. Then the same thing, okay? They ask for volume of hydrogen gas in set 1. Okay, so so uh again volume of hydrogen gas, simple set 1 okay, and then what the I get the time right? So yeah, that's why I say this sort of question I sort of try question around same, okay, around same format. So wait so 25 7.2, okay. So you can, I think you can even do yourself, right? MV over 1000, you get 0.005 mole. Ratio full acid to 1 hydrogen, same thing, okay. Divided by 2. Interesting, wait. Then you find the volume, multiply the same thing, the mole with the molar volume. Same thing. Can I? Easy, right? Doing the time will be easier, see? Okay. And then last part. Okay, can I? Give you 10 more seconds. Eh, got thing blocking the screen. What thing? Wait, black color. It's black color. Yes. I share again. Now okay already. Oh, okay. Okay. So they ask compare the reaction, same thing, okay? But now it's different factor. Between 1 and 2 is temperature. Okay. So set 2 having the higher temperature means higher rate of reaction. Okay. Then set 1 and set 3. Set 3 added catalyst. So set 3 got catalyst. That's why higher rate of reaction also. So explanation, 10 marks again, using collision theory, 10 marks. Okay. Same thing lah, each 5 marks, each factor 5 marks. Okay. So yeah, I'm gonna write down first. Okay, for set 1 and set 3, first rate of reaction is higher in set 2. Second, temperature, you touch the temperature. Set 2 uses higher temperature of mixture than set 1. Then temperature, remember to touch the kinetic energy. So kinetic energy of reactant particles in set 2 is higher. Then you touch about the more particles have energy to overcome the activation energy. Then the fifth and sixth point, same. Or you can straight away, if you don't want to say, you can skip the fifth step. You can skip. In this case, you can skip. Okay. So if you want more complete, you can write everything. But in this case, if you skip the fifth step, then the number 6 you have to say between zinc atom and hydrogen ion. You have to set up what particle it is. Okay. So F4C, F4EC between zinc, H plus. Okay. In set 3 is higher. The answer scheme got a bit wrong again. I mean set 2, sorry. Set 2. So many answers wrong. Wait I found out. Okay, this does. I finish everything. Okay, then I quickly go off already. Okay, then uh the catalyst what you say, okay, as you say, okay, rate of reaction in set 3 is higher because set 3 uses catalyst, or you can say uses copper sulfate. Okay, and then catalysts provide alternative pathway by lowering the activation energy. More reactant particles collect, or you can say, you can even say more, what particle? More zinc atoms and hydrogen ions able to collect, okay, to achieve activation energy. This point important also. Then you say frequency of effective collision between zinc atom and H plus in set 3 is higher. Okay. So again, okay, if either you can see concentration, size, catalyst, temperature, okay, they have their own a little bit of format, but at the end, the sentence around the same. Okay. So normally I send answers as soon as possible. Okay, I see you again. Goodbye. Okay.